A while ago, some artists invited me to help them with their little indie project. Previously, they'd been using Claude to try to do all of their coding for them. The results were less than beautiful code. Every feature seemed to have some condition where it would break. It was like being in a dream where you could reach out and the thing you tried to grab just disappeared in your hands, like nothing made any logical sense. So anyway, my official role became to de-shitify the codebase, to gut the AI, and cleanse the repo. But along the way, I made a terrible mistake. I began to have creative thoughts. You see, this game was mainly to function as a sort of art exhibit for the artists. It was kind of like an AFK game, but without the game, not to put it too meanly. They just want to make an environment that was like nice to be in. And the lead artist described it to me as intended to be something you just leave open on another monitor. So I began thinking, and I realized that this concept is basically like a live wallpaper. So what if we were to make the game itself into a live wallpaper, like one of those ones from WallpaperEngine, but this one would have a bit of interactivity. I presented my idea, the team loved it, and I got to work. So you might be thinking, like I did, isn't this simple? Like all you need to do is just put the window in the background, right? Yeah, I was in for a bit of surprise. You see, as coders, we do these things not because they're easy, but because we thought they would be easy. The main problem can be boiled down to this. We want our game to render behind the icons, but in front of the normal wallpaper. Windows, and probably other operating systems too, doesn't officially support this. So that means we have to get low level. The first order of business was to figure out how Windows renders the icons and the wallpaper, which brought me to WinSpy. It's not exactly intuitive, but essentially it boiled down to some background processes were handling this. But still, I didn't know how to get from that to what to do with our application. I found some people online talking about Progman and was able to find that through WinSpy and even tried some of their code out, having absolutely no idea what I was doing and unsurprisingly having no success. I wasn't even sure how to run diagnostics to see what I was doing. It felt like I was an archaeologist or a detective trying to discover the secrets beneath the windows. Then I stumbled upon something huge. WallpaperEngine already does what I'm trying to do, so I tried to learn about how it works, but it's closed source. But it just so happens that there's an open source alternative to WallpaperEngine, Lively, and it's written in C#, the language I've been programming our game in with Godot. Thank the heavens, thank Zeus, praise be to the spaghetti in the sky. I had finally found what felt like a strong thread on this case. I looked through Lively's source code and combed the repo, and not only did I find commented code about how to do this, I even found GitHub messages which gave an abstract tutorial on how to do this. Thank goodness gravy for Jens Roth. Although their explanation was in C++, it, along with the Lively source, was everything I needed. So here's the battle plan. Your desktop basically exists like this. You've got the program manager, Progman, which is the parent of two other processes which make your desktop. Shell DLL Def View, which displays the icons, and a worker window, which displays the wallpaper. It turns out that there's an undocumented set of numbers, hex 052C, which if you feed it to Progman, causes it to create a new worker window for us. And not only that, but it creates it right where we need it, between the icons and the wallpaper. From there, we can simply set our game to be a child of that newly created worker window, which will cause it to render between them. That's the plan, but now we have to actually do it. So step 1 of our baking recipe calls for getting the handle for the Progman. This is a pointer variable, which in Windows lets you know where a process, such as Progman, is in memory, so you can do stuff to it. After peering into the pits of the Lively source code, I discovered that the way you can get handles and do other low-level stuff with Windows is by invoking Win32 methods with pinvoke. Basically, Windows itself has a whole bunch of functions in its code in compiled binary, and pinvoke takes a look at that and translates it into C# in such a way that you can just right at the top of your application that you want to use that existing Windows function in your own program, and then you can. Specifically, the functions I want to use for our purposes are inside of user32.dll. So for step 1, we need to get the handle of the program manager. Well, it just so happens that there's a function for that. There's this great website called pinvoke.net, which lists a ton of Win32 functions and their declarations for C#. There are probably better repositories for this nowadays, like maybe CS Win32 or Win32 metadata, but something about a website without any formatting at all makes me trust it. You immediately know that this was created by programmers trying to help you and not business people. So let's see here. Here we are. Inside of Lively, we've got an invocation of find window, and it looks like just the thing to get the handle of Progman. And we'll look it up to learn about what's going on. So later we'll be able to do this stuff, even if what we need doesn't exist in Lively source code. So looking for it on pinvoke. Here we are. Find window. Wait a minute. Find window X? Find window A. Wait, what does the MSDN say? It doesn't even have an entry for find window. Okay, well, that's pretty much what my experience has been for the 2 days of me developing this. Looking at Lively's code, testing it out, looking at Microsoft's documentation, looking at other people's code online, searching pinvoke for notifications. You might think I could just copy all of Lively's code, but I really didn't want all those features. I just wanted to display our game's wallpaper, and that also have options for videos as wallpapers or a separate UI or anything like that. I also wanted to implement some of our own proprietary features, which I'll get to in a minute. So after a lot of trial and error, I was able to verify in each step what was going on with some diagnostics methods. And it actually fucking worked. Oh my god, I actually fucking got it to work. Oh my god. Holy shit. Okay, it's not accepting any input, but it's working in my desktop. Holy fuck. This took for fucking ever, by the way. I literally did this all day for 2 days. Let's fucking go. Now, slight problem. The keyboard isn't working. Actually, nothing is working. It turns out that Godot's input system, completely understandably so, only registers input when the window is actually in focus. That's pretty standard for most applications, but in our case, since the game is actually a wallpaper, it can never be in focus. That type of a window is not one that you can click on and interact with. So what we need is an input system that tracks input even when it's not in focus. Back to low level. I'll spare you the rest of the details, but in abstract, there are a lot of functions for getting input, and I was able to run those methods inside of the Godot project C# solution. Another common W. To do this, our class installs a low-level keyboard hook, and to do that, we must first create another thread. Therefore, before we close the game, we should also uninstall the hook and join the thread. At least, I'm pretty sure that's what you're supposed to do. I think otherwise there's a chance of a non-cumulative memory leak. So I did that in 2 ways. One, when the exit tree method gets called, and two, if the user closes the application via the system tray. Oh yeah, I forgot to mention that. So since the application runs as a wallpaper, it doesn't show up anywhere as a window. It's not in the taskbar, Alt tab, and it doesn't even show up as an app in Task Manager, but rather as a background process. So since we don't want people to have to open up the Task Manager and force close it every time, and since we want to be able to clean up these hooks and stuff, I decided to tie everything off by putting in a system tray icon with an exit option that also calls those methods to uninstall the hook, join the threads, close the Godot exe, and finally to, of course, close the worker W process. All right, scared. Oh! It's so loud. It's so loud. Turn it down! Turn it down! Okay. Oh my god. Now, the moment of truth. Oh my god, the input works. Oh yeah, let's go! Dude, it only took me all fucking day. Dude, the game literally fucking works on your desktop now. That's so cool. I was really happy with this. A working game as a wallpaper, but like a lot of low-level stuff, it worked on pretty much no other computers. Since everyone else has different versions of Windows or may not be using Windows at all, or who knows what else, different parts of the process can fail. I did manage to get it to work on one other person's computer, and I imagine with more development time, I could resolve a lot of these issues. But I think the lesson to be learned here is that there's a reason why we got away from low-level stuff and into abstractions. Compatibility and development time are huge factors, and I think there's a reason why applications like Lively have involved a lot of development time and many, many contributors. Thanks for watching.